Supplemental math videos from Circle Christian School. Polynomial operations. Like the name represents, it's multiple variable terms being combined together. And if you think about it, if you were to put a number in for x, it would just give you a real number anyway. And because it gives you this real number, then you can add them, subtract them, multiply them, and divide. They're just really complex numbers. Before we can talk about polynomial operations, we have to talk a little bit about the polynomial. Polynomials are just variable terms being added and subtracted together, combined. We'll start off with a monomial, like 4x to the third power. You'll notice that all it has is the the coefficient, that guy, the variable, and some sort of power. A binomial is, just like it sounds, has two terms to it. Things that can't be combined. Trinomial, 3 terms. And then we have a special trinomial that you'll remember, the quadratic trinomial, or the quadratic equation. The quadratic equation always has x with the power 2, and it makes those cute little parabola guys, the smiley face and the frowny face. Oops, the eyes don't really go there, but you get the point. And then the polynomial, many nomials, many terms inside there. Coefficients are the number in front of the variable. For instance, the coefficients here would be 6 for the first term, a positive 8 for the second term, negative 2 for the third, positive 5, and the negative 1 is a constant number. And then we can talk about the leading coefficient of any polynomial. And the leading coefficient is just going to be the guy with the highest power. He should sit up front and everybody else follows behind in order. He has what is called the highest degree. A degree is the highest power of the polynomial. So this is a polynomial of the 4th degree. Because polynomials are just real numbers, we can add, subtract, and multiply, and divide them. You just have to remember the rules. When adding and subtracting, it's combining like terms. But these are going to end up being big old hairy polynomials as we add them. So for instance, if we had x to the third power plus 3x squared minus 4x plus 6, and we were to add it to another big old hairy polynomial like negative 8x to the third power plus 9x squared plus 5x minus the 2, we would just add them together just like we would two big numbers like 63,000, 248 plus 79,624. That we would just add them together like we would any number. The difference is usually these are presented horizontally, and nobody likes to add things horizontally or subtract. We like to take them and make them vertical so that we can do the proper place values. So for instance, I would do 63248 up top, the 79624 down below, and we would add them together that way, just like this. And we would proceed with the ones place, the tens place, so forth and so on. Well, I like to do the same thing with the big old hairy polynomials. I like to take whatever's happening first and write them in order, and make sure you leave a little place if there isn't a value there for a certain degree. I'm going to add it to the second guy. Plus a 9x squared plus 5x. Hanging around in the background is my son from Atlanta and his pretty little girlfriend. He's the guy who's Mr. Ditch the Demon. So we'll just pause at this moment and remind you that the best saw blade in the whole wide world is the Ditch the Demon saw blade, the Diablo saw blade. And then we would just work and combine the like terms. You'll notice I start off on the right just like I would with the big number here. I would start with the ones place. I just have a habit of doing that. Doesn't mean you have to because they're just like terms anyway. You just have to make sure you put the sign with it. And you can put the 1 in front of the x. And then we have a 12x squared. And you can put a 1 up here too, just so that you can recognize that it's 1. Take away the 8, or a negative 7x to the third power. So adding and subtracting these are just like you would any number. The only caveat would be that you have to remember that if there's a minus sign in between, that it's not just saying minus the negative 8, it's saying minus everyone, and you have to distribute that out if you're going to do vertical subtracting. All right, let's go a little bit to multiplying these polynomials. We can do a monomial multiplied to a polynomial. We'll just do a binomial at this. Well, no, I'll do a trinomial just because it's more fun. In fact, I'm going to make it even bigger. I'm going to make it a polynomial because it's really fun that way. So what I'm going to do is circle it. This is my advice for working with any type of distributing. Circle what's being distributed along with the sign. Give yourself the little arrows just so you can follow along the way. And remember to multiply number to number and letter to letter. So we have 2 times the 3, which is a positive 6, and an x to the 5th power. Remember your power rules, same base times same base. Just remember to add your powers together when it's same base times same base. Next one's going to be a negative, science first, math second. There is a hidden little 1 there, so 2 times the negative 1 is the negative 2, x to the 4th. Going to be positive, so we have a 2, x to the 3rd. And last times a positive 1, happy days, stays exactly like it was. Okay, let's try one where it is a little bit bigger, where we're going to have a binomial times a binomial. 3x plus 2 times 5x minus 1. And here you're going to super distribute, which is the same thing as foiling when all said and done. But again, I'm just going to circle what's being distributed first, which is a 3x. Give myself some little arrows to go and follow. And again, we're going to go with the number to number, letter to letter thing. So 3 times the 5 is a 15, and then an x squared, letter to letter. And the 3x times the negative 1, negative 3x. Talk to yourself while you do this. Things like that really do help get away of the silly take those silly mistakes away. And now we're going to distribute the other part of the first part into the second. Positive 2 times the 10x is a positive 10x. Put the sign with it. Keeps you from messing up those little integers. 2 times the negative 1 is a negative 2. Note I do my combining very vertically. You can do side by side, not a problem. And now we're going to get the 15x squared. Combine your like terms here. So I'm going to get a positive 7x and then the negative 2. All right, let's try one that's just a little bit bigger. Let's try a binomial being multiplied to a trinomial. So 2x oh, let's say plus 3. My favorite ones anyway. 5x squared plus 2x minus a 6. There we go. And watch as I circle again. Same idea. It's just, this is going to be super foil. Super distributing. Run your arrows out. And I'm just going to, again, multiply number to number and letter to letter. So we have 2 times 5, 10x squared times, the x times the x squared is x to the third. 2x times a positive 2x is a positive 4x squared. And the 2x and the negative 6, negative 12x. Change colors. And now I'm going to distribute the 3, positive 3 to everybody. Notice how I also circled the plus sign in there, just so I don't lose the sign. And you move 1 over because we're working with x squares. So we get a positive 15x squared plus a 6x minus an 18. And there's my vertical combining of like terms. So we have the negative 18, negative 6x. This is an x squared, 19, 19x squared. And it's positive, and 10x to the third power. And you have nothing anymore to be afraid of, because you have tamed Harry, the big old hairy polynomial. Go have an awesome day.